How are you today?
Hey, it's been a day.
Yeah, no kidding.
How you feeling?
I'm doing all right. My throat's a bit raspy, but I'm doing okay.
Did you run fevers with all this thing?
Um, or last week I was running a fever, but this week I'm doing okay. Better than I was last week, anyways. So
How did you already go through the review material?
the review packet, the one that was,
Yeah.
this packet, yeah, I
Yep.
printed it off. Some of it I just did. Some of it I was like, I'm sorry, what? Like some of it was just kind of like that for me. And majority of it I got. At least I feel like I got it just fine. It was when we got to this last set of questions though that I got just confused there, and I just couldn't remember exactly what to do. And I was trying to find it within all of our work.
What, like 19 through 24?
Yeah, let me go. 19, I think I got okay, but I don't know about that one. 20 through 23 were just, I got so mad working on those ones, but I think I got them. It was mostly 27 through 31 that I felt like I really just didn't understand.
Okay. Um,
Those will have to go over a little bit.
I think you're right. I find that when we do these sessions, I'm a really long test taker, I think. And I
Yes, you
find,
are. That's okay.
and
Where'd my pencil go? Oh, there it is.
like the last two exams Saturday night, I did fine on them, but I take a long time to just really go through stuff. I want to make sure I'm not missing something. But on these, I feel like I'm as quickly as you guys want to be on this.
No, you're fine. It's okay. The only I felt like I dropped something and I just don't know what it was. But my only thing now for tonight is my husband surprised me on Saturday. His parents flew him up here and nobody told me. And I got home and surprise.
Does he work out of town?
Yeah, he doesn't work in state. He works out of state.
What kind of work does he do, if you don't mind me asking?
Oh, you're fine. No, he works construction in Idaho. When the construction in Idaho, when winter comes around, the majority, if not all, construction companies close for the season. So he has to find work elsewhere. And he goes down to New Mexico during the season to work for his family's company. So he's been in New Mexico for the past 4.5, 5 months.
That's a lot of time away. Hey,
Yeah.
looks like Naomi's here.
Hi, Naomi.
Hey guys, real
Hi.
quickly before Kristen signs on, I'm just gonna grab a quick drink. I'll be right back, and hopefully I'm not. It'll take me all 60 seconds. Y'all cool?
Yeah, you're
Yeah.
fine. I'll probably do the same. So I'll be right back.
Okay.
Do we have anything caffeinated? Ow.
Looks like everybody had the same idea.
What?
Getting a drink, getting something.
Yeah, I went to go grab a drink, but I we don't. I thought we had some some Coke in the fridge and we don't.
Well,
That's what I was hoping for, but oh well.
all right. How confident are we that Kristen's going to join us tonight?
She said she was gonna be a little late. Um, Not sure why, but that's what she said. Yeah, she said she's gonna come a little late, and I said I'm gonna just text her back and say, okay. Okay, period. We just started, so hopefully you can get with us soon. Period. Send.
So I started some of this.
Some of what?
Because it's
The quiz?
Yeah, the quiz. It's a review for the test, so.
Okay, that's nice.
Well, looks like we're all on the same sheet of paper. Do you want to wait for Kristen, or does she just want to join us when she joins us? What's your general feeling here, Shalise?
I think we should start now.
But. Okay.
I think she might just join us when she joins us. I mean, that's what I would expect you guys to do if I were coming late.
Me too.
Pose her question if she has an outstanding one. Should we just start with like question 1 and just see if we came up with the same answers? If not, we'll just hit the high points on it, see if we can resolve anybody's concerns, move on.
Just through the packet?
Yeah.
Okay.
There's only, what, 32 questions?
Yeah, there's a total of 32 questions.
All right. So, you can, Naomi, Shalise, any of you can start reading the questions. I'm just going to start with 1 and 2. For number 1, I just came up with a central limit theorem, same as you.
Yes.
Number 2 is the law of large numbers.
Yeah.
With number 3, following which ones are categorical, I basically put number 2. How did you feel about 1 and 3?
See, I wasn't sure. I knew number 1 wasn't it, but I was kind of stuck at 1 and 2. But I can see where both of them would be good, but I was leaning more towards number 2, just because, the age and years of a randomly selected vehicle in a parking lot. That has to do with, age, number, and then, oh my gosh, I don't know why I didn't think about this earlier. Yeah, a randomly selected brand of toothpaste, and that's...
Yeah, that's what I put. I just put number 2.
Okay.
Gosh, I don't know what it is, but I just didn't... I didn't think about that earlier, like sitting here like, oh, hey, age is a number, toothpaste brand is a brand, it's a category. Wow.
So, 1 and 3 were not categorical, correct?
Yeah, they were,
Yeah, those were quantitative.
Yeah, those were quantitative. Thank you for saying that.
Number 4.
Also, to let you know,
the
quiz is the same as the little page before.
This whole thing?
Yeah.
Oh, okay. Well, then let's go through this completely, then, David, and then we'll start the quiz. Sounds good to you guys? Because that way we can work it all out and see what the issues are, and what we do and don't agree on, and go from there.
The quiz is 32 questions, Naomi?
Well, let's see. The quiz started with, I completed the part 1, and I attended my group, and then number 3 started with the categorical. The selected brand of toothpaste. That's what it started on.
So have you already done your quiz then, Naomi?
Yeah.
Okay, and it had 32 questions on it tonight?
Full of 35, but with the 2, the 2 freebies. So 33.
Okay. All right. Well, in that case, for number 4, I put that the 100 for the United States was the parameter versus 112 was the statistic.
Me too.
Okay, I got the 112 of the statistic. I don't explain the parameter to me, David, because I put 20 down.
A parameter is a number which describes a population, whereas a statistic is something that's derived after a calculated a calculation of a variable.
Okay, so the parameter is the population.
The parameter is the description of the population.
Okay, let me write this down then, just so that I have a better
And
description.
I actually have it with my notes downstairs. I didn't bring it up here. The only thing I'm holding right now that I brought upstairs here was just the review. And quite honestly, when we're going to get to some of these, I didn't put a number. I didn't put a number down, or I didn't go into the SPSS and work some of these. Naomi, did you go through and do the entire 35 questions already?
Mm-hmm.
All right. Well, you're ahead of me then. I didn't even. I'm like, tonight I'm going to stay up late and I'll do all this and blah, blah, blah. Did you already take the test too, Naomi?
No, I'm not the test yet.
All right.
Not that far ahead.
All right. Shalice, did I leave you with?
Number 5 is what we're on.
All right. I thought. What did you think 5 was? I went with stratified random sample, but little question mark there.
Well, because I was either thinking stratified random sample or cluster sample, but that sounds, I just wasn't completely positive.
I put stratified.
I was a little had a few questions about this because if 5, 6, 7, and 8, I would think they were all going to be different answers. And it seems like I came up with 2 of these described stratified.
Yeah, I had number. Well, let's go through number 6. Number 6, I had cluster sample for number 6.
Yes.
Yes.
Okay. Number 7, I had simple random sample.
Yeah.
Yes.
And number 8, I had stratified sample.
Yeah.
That's what I went with.
Okay, that's what I had as well. Number 9, for the mean, I got 4.771. Did you guys get that too?
Yeah, I did.
I did not do 9 or 10.
Okay, but Naomi, is that what you got?
Yeah, I got 4.771.
Okay. And what did you get for the standard deviation?
I got 1.912.
Okay, yeah, that's what I got as well.
Was that off the data that they showed when you pull up the SPS? That was just based in that data table, wasn't it?
Yeah, I was in that data table where you have to go to analyze and then I can't remember the exact steps, but it's like analyze, descriptive something, and then explore, and then you're able to, it'll give you all those options.
I looked at some of these and thought, man, I don't have time to go into SPSS. I know how to do that. I can just get off the data table, so I rationalized not a lot of these.
Save time and get your work done. Yeah, you're all right. Naomi, for the minimum, I got 0.84. Is that what you got?
Yeah.
What did you get for the max?
Well, I didn't actually do that one actually because it's not in the quiz. So I didn't do the one before.
Okay, Chris, for the max, I got 10.45. The first quartile, do you have your paper in front of you, though, Naomi?
I'm pulling it up right now.
Okay, because I'm just making sure that I got the right answers for these because, I don't want to be completely off and thinking, oh yeah, I'm doing great, and then I go take the exam, and then I'm like, oh no.
Yeah, let me just pull up my paper I did.
Okay.
I didn't print mine out. I just did it on Word.
Oh, okay, that makes sense. I would have, I printed mine out just because for me, it's easier for me to write everything out and everything versus, so it's kind of. And did you say that all 32 of these questions were on there?
Well, it's not on the min-max is not on the quiz.
Okay. Okay. But for number 10, number 10 is just on SPSS. You have to be able to do that yourself. David?
Yep.
Were you able to finish the table?
I did the table on page 6 out of 9, which was about Bodil, Roberta, Larry, and Fur.
Yeah.
Yeah, I did the table on that and came up with some final numbers. Did you do it?
Yeah. Oh, yeah, I did. Um, for Bodil, for the deviation from the mean, I got negative 0.65. Is that what you got?
Well, no,
Okay,
because
okay, then I'm probably way off because I had a hard time finding the mean.
so I added all those together. 30 for Bodil, 37.91. Roberta, 37. I had all four of those together, and then that gave me my mean.
Divided by the 4. Yeah, I got, for the mean, did you get the 38.075?
That's what I got. So I took 37.91 minus 38.075, and I got. Let me just see if my math, and it could be me that just screwed up on the math of this here, but hold on, I'm pulling up the wrong calculator here. So if I went to 37.91
Minus
oops,
38.075.
37.91 minus 38.075, 38.075, I've got negative 0.165, which is a deviation from the mean.
Yeah, I got negative 0.165.
Oh, I thought you said negative 0.65.
Oh, no,
Okay.
1.165.
All right. So then for Roberta, my deviation from the mean was negative 0.825.
That's what I got as well.
For
Larry?
Larry, 0.905.
Yeah, and then for per, I got 0.085.
That's what I've got.
Okay, so
Now,
then for the squared deviations for Bodil, I got 0.0272.
yes, and I went all the way 5 numbers,
Yeah,
but
I did
either
too. I
way.
got the
So
225 at the end.
same number, Roberta 0.680625,
Yep.
Larry 0.819025, and per 0.07225.
Wait, for pair, did you get 0.007225 or 0.07225?
Well, let's do the calculation real quick so that so I've got 38.16 minus 38.075 equals point. Okay, I've got that.
0.085 squared.
0.085 squared gives me, yeah, you're right, 0.0075 or 7225.
Okay, yeah, that's what I got as well.
In that case, that's going to screw up my calculation at the very bottom, so I will be off. But
Wait.
rough,
Okay, so did you guys get what's the value of the number that goes in the position marked with B for Roberta?
For B, for number 11, I got negative 0.165, and then for number 12, I got 0.680625.
Okay, but then does that round up to 1, right?
That rounds up to 0.681.
1. Okay, cool.
what
That's
you
what I got to.
were you talking about the value for B?
Yeah.
Well, if 0.825 squaring that, I thought that was 0.680625.
Yeah, but rounding it's 0.681.
Yes,
Because you have
okay.
to round the 3 decimal places.
Well, you remember in that, did you guys read the preview for the week that he came out with Monday night?
Oh no, I haven't watched those yet.
So one of the things he said in that was just be careful. He said, be careful about take all your numbers. If you have beyond 3 numbers, he says, just take all your long numbers and add it all together, and don't round until the very end. He said
Yeah.
because if you start rounding early, you'll end up with a skewed number at the end, and just that little bit. So that's the reason I didn't round with these. I mean, I added the whole number.
Yeah, that's what I did as well. The only thing is on the quiz is what she's saying on the quiz for that
Does it have you
answer.
round to
It
three
it
digits?
has to be rounded to 3
Got it.
decimal points.
Understood.
Yeah.
Okay.
What did you get for 13, David?
Okay. I put it was the variance because when you take all these squared numbers and add them together, that the quantity is equal to the sum of the the variance is actually those numbers divided by n minus 1, correct?
Yeah, it's the sum of those numbers divided by n minus 1.
And then when you get that number, which is, mine's going to be off, but the sum of those numbers, 2.3 something, right?
Let me double check that real quick, just because I got something different.
I'm gonna have to re-add my stuff. Naomi, you've already done this, so my apologies.
No, it's okay.
Oh, good gravy. That is really messed up. 6, 8.
So when I re-add all that correctly, I get a total of what, 1.5341?
Yeah, I get 1.5341.
All right. So we would take that number and divide it by 7.
7? Why 7?
Well, I'm sorry, not 7. We would divide it by 3 because there's 4 samples.
Yeah.
So the sample's minus 1 divided by, so it was, let's see, what was it, 1.543?
1.5341.
1 divided by 3.
Yeah.
So we have a variance of what,
511,367.
Yeah, or 6, yeah. So it would be 0.512, or excuse me, 0.511 is our variance. If we take that number and square root it, our standard deviation is what, 0.715? If we were looking for the deviation. So the real answer to the question of 11, the quantity is equal to the sum of the numbers in the squared deviations column. Or what quantity? Well, it's not the mean.
Well, my thing is that the variance is divided by the number of samples minus 1. So would it actually be the variance? Because when you're adding them all together, it's 1.5341, not the 0.511367.
You've got a point. So what does that sum represent? If it's not, it's a pre-variance number. What do we call it? It looks like the brains of the outfit just signed on. Maybe she knows.
Hey, Kristen.
Hi, sorry, what number are you on?
13.
Okay.
Okay, so in the reading, it says divide the sum of the square deviations by n minus 1. And then later it says the number you computed in step 5 is called the sample variance. So it would be variance, right?
So it would be the sample variance. Would that be kind of like the sample mean and the mean being the same thing, do you think, David? It would be the sample variance and the variance?
It seems like we're kind of, I don't know what they're asking for here. It seems like we're playing a semantics game. Not us per se, but is this a trick question? Because the true variance is not just those numbers alone.
Yeah.
Variance is those numbers divided by n minus 1, which would be divided by 3.
Yeah.
So
me personally, I would put none of these as correct because it is just asking for the sum of the numbers in the squared deviations column. It's not asking for the sum of the squared deviation columns divided by 3. You know, it's not, I feel like it's trying to kind of trick us out here with making us think that it's wanting us to pull for the variance. But in reality, it's none of these is correct.
That's rude.
Or maybe it's the other way around and I'm totally messed up.
Well, last time, just a quick step back to last test. I had none of those problems when we took the test for section 7 that we had during the group collaboration. And that was because that sneaky little word they slipped in there, which was although they didn't give us, they didn't ask for the mean of the sample means, they did say that little Q word, which was, what is the mean? And so when I made that correction when the test came, didn't have any problem with that type of question. Did either of you, or did any of you?
Sorry, I'm still trying to catch up.
Okay, so roughly, you know, when we had questions 8 and 9 and we missed them, and we didn't know whether or not they were just talking about the mean of sample means, or they were just talking about the mean, and we were trying to find out.
I
Okay.
remember that.
Oh, last week? Are you talking about last week?
Yeah, so if you look back at those questions, they each contained that very small word, which it didn't say ask for mean of sample means, but the code word there was, what is the mean of the variance, or whatever. It was something, they included the word mean, which was the clue to, oh, now's when we have to do the, that's when they're looking for the mean of sample means. So when I applied that to taking the test Saturday, I had no trouble and got the questions right, and it was that little thing. So why am I talking about that? Well, is this one of those things where it's just simply the variance and they're not trying to get too tricky? Or are they really trying to get tricky and make you realize that the sum of those numbers, even though they're not divided by n minus 1, it means variance? Or does it actually just mean, gosh, it means something else, and variance has another step before you get to true variance?
Actually, David, I think you have a point, especially since you brought up last week's quiz. I think you have a point, because it could just be saying don't be stupid and don't try to trick yourself into picking something that's not right. I think you might have a point.
Naomi, I think you probably have to recuse yourself from these questions, right? Since you've already been through it?
Yeah.
Okay, that's fair enough. What is the standard deviation of these temperatures? Question 14. Well, what did we come up with on our calculation for standard deviation? Point what? 0.715? Is that what you got, Shalise?
1 second. Let me check this real quick.
If our variance was that 1.534, whatever it was, I square rooted that for the standard deviation and came up with 0.715.
Sorry, 1 second. I had the wrong stuff written down, so let me just double check. Yeah, I got 0.751.
751 or 715?
751.
All right. What did we come up with for variance then? Just real quickly. Give me that number one more time if you don't mind, since they're 1.5 what?
It was 0.511367.
Was that what you got for the sum of all these numbers, the 0.6 and the 0.8 added together? From all these squared, all the variance, all those variances added as squared and then added together.
That one. Oh, okay, I'm sorry. Yeah, it's 1.5341 is the sum of the squared deviations.
All right, so when I take that number and square root it, that's wrong.
Because then you have to divide it by 3 and then take the variance and take the square root of the variance.
Okay, so we divided that by 3, which gave us 0.111 or 0.51. If I take that number and square root it,
yeah,
I'm getting 0.715.
Oh, I'm sorry. Yeah, I'm sorry. I wrote that down wrong. I'm sorry.
Oh, you're fine.
177. I wrote 0.715 on this side of my paper, okay, and then I came back over and put 5.1. Sorry about that.
Kristen, have you already done all the exam review sheets 1 through 32 questions?
I haven't.
Okay.
I just have a question. on like 12 through 15, did you guys just find the mean yourselves?
Yes, we added the 4 numbers up from Bodel,
Or
Roberta.
does it give the mean somewhere? Because I can't find it.
We have to add it up, and we have to find the mean ourselves.
You have to take all those numbers together and then
Sorry,
divide.
what was that? Okay.
I said you have to take all those X numbers for Bodel, Roberta, Larry, and Per, add them together, divide by 4. That gives you your mean. She's gone.
Yeah, her internet connection isn't all that great.
How's everybody feel like they're doing in this course so far?
I'm feeling pretty okay.
Okay.
I'm feeling like I'm doing a decent job considering, you know, I'm used to more of a classroom setting as far as math goes. So so far online, I'm feeling like I'm doing all right.
Okay, Krista, did you get the answer that we were talking about? How to get the mean?
Don't you just add it up and divide it by 4?
Yeah.
Yes. Yeah.
Okay. Perfect. I got it. Thank you.
All right. What, on to question 15 now?
Yeah.
Under certain circumstances, the standard deviation can be negative.
I put false.
I put false too.
Yeah, I'm pretty sure that's false.
Well, the standard deviation cannot be less than 0.
Oh,
But we
that's
can't, right?
Yeah, you're right. Cannot. Yeah, let me emphasize that.
But it gets a little tricky when you realize that certain people's standard deviation, they deviate away from the mean, but that number, we can perform less than the mean, but it's not necessarily a negative.
No, you're right. Because I mean, I had false for it because I was sitting there and I was like, I don't think it can be less than 0, but I wasn't entirely, you know, right on the dime.
All right. The question just underneath the graph, which location resulted in the most consistent temperature measurement from one seal to another? Justify your answer.
Are you on number 16 now?
I was actually on, yeah, I'm on 16.
I put extradural because it's the smallest standard deviation.
That's what I've got. I mean, if
Yeah.
the numbers alone.
Yeah, just from looking at the numbers alone, I would put the extradural because it's the smallest standard deviation.
Anybody else want to take it from here?
For number 17, I wrote down the standard deviation is the variation from the mean. So unless someone has it in a simpler form than that.
Yeah, just how far away a value is from the mean.
All the same answer. Agreed.
Okay, just checking. Okay, for number 18 on this box
Oh, yeah,
plot.
that's great. I think that's perfect.
For number 18, for the minimum I've got 2. For the maximum I've got 12. Does everyone agree with that so far?
Yes.
Yes.
Okay, so the quartiles in the box plots I tend to get a little mixed up on, so tell me if I'm totally messed up or not, okay? So for the first quartile I have 4. For the second quartile I have 6. Does that sound right, or am I way off on this?
The second quartile or the median, yes, 6.
Okay, and then for the third quartile I have 8.
Yeah.
Okay, and then for the first quartile, did you get 4?
Mhm.
Yes.
Okay, well then that's okay. I was just worried about that one because I was thinking of it and I'm like, this makes sense. You know, this to me looks right, but I just wanted to double check. But thank you. So for number 19, this is something that always gets me every time is when it's asking for the percentage of the data, you know, that lies within the box. From here, I have 50%, and the only reason why I say 50% is because, you know, from 4 to 8, you know, to 4, actually, I should have probably put a third of it. But I don't know.
Well,
What'd you
on this one, so it goes from 2 to 12, so there's a total of 10 units on there. So how many of it lies between 4 and 8? So let's see. So 4 to 8 is 4 units, so it would be 4 units out of 10. So wouldn't it be 40%?
David, is that right? Is that what you got?
That's a kind of a tricky question, Kristen, and I'm not sure that I'm going to suggest the right thing, but just looking at if 4 represents first quartile and 8 represents the 75th percentile or third quartile, the amount of data between 25% and 75% is 50. So I was deducing it that way. Am I right?
Because that's what I had 50% down the first time, but I just don't know. This is one that gets me every time.
So I got a guy in my ward who's a statistician. He gave me about 20 minutes of his time this evening. I just went and asked a couple of highlight questions. Didn't do the question. This is one of the I had 3 questions for him. Question 17 or question 18 was one of the questions that I'd circled because I thought, well, I put down 50%. Do you? And I had him look at this and said, I mean, is it really 50%? Because you would think if it's between 2 and 12 that I would be somewhere between 5 and 9, but the data, the plot itself shows that the bulk of the data is between 4 and 8. So when I asked him that, he said, yes, that's 50%. Take it for what it's worth. If you do the quiz tonight and choose that this is wrong, it's hooray for you, and I hope you get it right. I'm going to choose to say it was 50%.
Well, my thing is every time I tend to not go with my gut, I always end up getting it wrong. So I'd rather just stick with the 50% than mess it up.
Okay.
So, I mean, because the 50% is what I got on it.
And I got 50% too.
All right.
All right.
For number 20, for the estimation for the mean, I got 2.055.
That's what I've got.
Oh, okay, good. Oh, okay, good. Okay, because I was really worried about these ones because I had some trouble, and I'm not gonna lie. Oh, I was so mad. Oh.
Well, so this is the other question I asked him, and I worked this entire thing with him because this isn't our normal one where you get 5 or 6 different, or take 5 questions ago we get 4 different data. We're talking about let me just get back to this. We're talking about Bodel, Roberta, Larry, and Perk. In this, you have a range from 1.5 to 2.52. You really only have 2 data points, and so trying to find the deviation from mean on these, they're both the same, but they're not truly. It's not like you're measuring. Measurement 1 gave us 1.59. Measurement 2 is 2.52. They're just saying that the.
It's just showing that range is there are 2 standard deviations away from the mean.
Right.
So that's what I'm getting from it.
So it was a bit tricky, but yes,
yeah,
you're right. That's exactly what it was.
So for number 20, I was able to get it by taking 2.52 plus 1.59, which I got the 4.11 divided by the 2 to get the mean for it. So from there, for number 21, for the standard deviation, I got 0.2325. Does that sound right to you, David?
Take a step back. Estimate the mean of measured nitrate concentration. So the mean is just 2.055, correct?
Yeah, I got 2.055. Sean? What? Would you mind shutting that door? Oh. Sorry, it's just really loud. I can't hear him. Thank you. All right. So for 21, for the standard deviation, I got 0.2325.
All right. I have a deviation of 0.2325.
Oh, yeah, David. You know what? Cyber high five. Feeling pretty good.
and we got that standard deviation. We just basically took the mu.
Yeah, because it was saying that 1.59 and 2.52, that each of those were 2 standard deviations away from the mean. So what I did is I just took the 2.055 minus the 1.59, which I got the 0.465 divided by 2 to get half of that to be able to get the actual standard deviation.
Now, tell me, I think I did this a little bit differently, but came up with the same number here. Because for 2 standard deviations, that's the 95%. We're talking only about, when I minused, of course, I've got a negative 0.465 for 1 standard deviation to the left and 0.465 for 1 standard deviation to the right. That's what you've got?
For 1 standard deviation, well, because what I read it as was that the 2.52 was 2 standard deviations away from the mean.
Yes.
And as was the 1.59, correct?
Yes. When I measured in the 0.465, it was just a variance from the mean. But yes, 2.52 is 1 standard deviation, so half of that is what you're talking about.
Yeah. So I took the 0.465 and took half of that, which divided by 2, which I got the 0.2325 to get my standard deviation. So for number 20,
0.2325.
Yes. So I mean, whenever it comes to equations like this, I'm kind of like, I'm going to find the easiest way for me to be able to understand how to do this so that I don't confuse myself later.
Okay, between what two measured nitrate concentrations do approximately 68 of the data values lie?
What did you get for that, David?
1.8225 and 2.2875.
As did I. Yes, those are the 2 that I got. Okay, so 24 through 30. 24, 25, and 26, I believe I have. 27 through 30, I don't quite understand how to do that. And I tried looking it up and tried figuring it out, but I just, for some reason, it just was, it was not connecting with me. So, but for 24, I did, however, get negative 0.3509 for the z-score, which in turn, oh crud, what is probably the random selection score above? I don't know why that didn't go down. Sorry, 1 second. Let me go back to my applet so I can complete this one. I didn't realize that I didn't finish it. What's your point? Of 542.3 above 0.362. Okay, so David, for number 24, what did you get for 24? Because now I'm kind of...
I can't tell you. I did 24. I looked at that and thought, okay, I think I know how to do this, but let me just pop through it real quick.
Okay.
Our mean is 542, 542.3. What is the probability that a random selected student will score above 542? So first we've got to find a z then. So if the mean is that, that's 50%, right? If the mean is 542.3, you with me, Shalise?
What was that? I'm sorry.
Is the mean, okay, so 24, the question is, what is the probability a random selected student will score above 542.3? Well, looking back in the previous paragraph for the data, it says the GMAT scores are normally distributed with a mean of 542.3. So if the mean is 542, that's 50%. What's the chances of scoring above 50%?
Okay, that makes sense.
50%.
Oh my goodness, that makes sense.
Do you get that? Do you concur with that, Naomi? Or do you have to refrain from concurring?
No, yeah, I concur with that.
What is the probability the random score will be below 600? So basically, we're talking 600 minus 542.3 divided by the standard deviation of 120. So I don't have the applet up, so
I do.
Okay, outstanding. So if we do 600 minus 542.3, that gives me a number of 57.7. That number is going to be divided by 120.54. I'm getting a z-score of 0.47, call it 0.477. Excuse me, 0.479. So,
Let me go ahead and enter that.
You're going to put that in, and then you're going to shade to the right.
0.3160.
So 31 people will score above.
And that's to the right of everything in general. That's not under the area of the curve.
Right. So what percent of that 31%? What or that 30? What number does it say? Yeah, forget it. It's 31%.
And wouldn't that be the same for 26 because that's below the 600, or would that also include the area underneath the curve?
I've got this backwards. So number 26 is 31% because it's greater than 600. 25 is going to be below 600, so shade to the left. So
is that going to include the area under the curve as well?
So anything below 600 is area under the curve plus everything to the left. That would be 25's answer. And then 26's answer is shaded to the right.
Okay, so then 25 is 0.6840.
So 68%. All right. Which seems a little bit odd that if the mean is 542, people can't score 68% of all people. Well, that makes sense because that's within one standard deviation.
Yeah, that's what to say. That's within a standard deviation.
All right. So then 26, we got what, 31 point something, or 0.3.
Yeah, number 26 is 0.3160.
All right. Okay. Now with that, I just go to the very top box and type in 0.1, and that should give us the 10th percentile.
Oh my gosh, why didn't I do that? I'm sorry. For some reason, I was just having the hardest time with this, and I don't understand why I was having a hard time. I just think I was just having a bit of a brain block, maybe.
Now, here's my question, which I've had a little bit of struggle with. Once we type in that percentile, that gives us a z-score. To solve for x, because they want to know what the score is for the 10th percentile, to solve for x, I can't remember the formula, but it's x equals, what, z times, z minus this times, I can't remember what the formula is. You girls remember?
Ouch.
What number are you
I'm
on?
sorry.
So I was going to say verse 27, Nephi 27, verse. So number 27.
Thank you.
Find the GMAT score that corresponds to the 10th percentile. This requires us first typing 10 into the top of the applet.
Yep.
That gives us a Z number, and the Z score is what we really need. So we have to take the Z score and plug it into a formula. The formula is, because we're solving for X here, X is that number, somewhere in the 400s or whatever, or 300s, that tells us the 10th percentile. But we have to take X equals, and then it's I don't have that in front of me, but it's a formula for finding out what X is. So it's X equals Z times something. I can't remember what it is. Do you guys remember the quick and dirty formula?
No, I don't, but I can figure it out otherwise.
There is a longer formula, which is what we do Z equals, you put Z on one side and then put X minus Y divided by standard deviation. You just want to get everything out of the way, and you just want to solve for X in that equation.
That's what I'm doing right now.
So what's your Z score on that anyway?
Hold on, I'm getting there. 1 second. 12.05. equals x minus 542.3.
Hey guys, I'm sorry, I have to go.
All right, take care.
Okay, well thank
Have a
you.
good night, Naomi.
Okay, you too.
Okay, so for the GMAT score for number 27, I got 554.35.
Now that it's got to be, if the mean is 542, we probably can't have a score that's higher than the mean and be in the 10th percentile, right?
That would make sense. Let me see what I did wrong.
What did you get for a z-score?
For the z-score, I got, oh my gosh. Oh my good gravy, I feel like such an idge tonight. Good gracious. Sorry, I didn't even use the z-score. I used the 10th percentile. Huh. I went 0.1 instead of the z-score.
Gotcha.
Oh my goodness. David, what is wrong with me tonight?
Same thing that's wrong with me this entire course.
Okay, 1 second. Let me erase this and go back and work on that one more time.
I'm going to work along with you, see if we come up with the same answer. What do you have for a z-score?
Okay, so for the z-score, it's 0.126.
Okay. So then we're going to say 0.126 equals x minus y divided by the standard deviation. But now we're just going to plug in numbers and solve for this y on this, the mu, excuse me, not mu, they're not y, but mu. Mu on this is 542.3. And then our standard deviation, we know, was 120.54. So if we take 120.54, right, and we divide by 120.54,
Hold on a second, I'm getting there. Okay, alright, I'm still not, what am I doing wrong?
actually we're probably doing just fine.
Where did Naomi go?
She had to go.
Oh, sorry, my internet keeps going in and out, but I think I fixed it.
It's all right. Naomi's already completed the quiz and she's already done the test. I mean, or not the test. She's already done the quiz for the night. She's already done all of her homework. She's loads ahead of us.
Oh, wow. Good for
And if I had done that, I would have looked at you guys and said, man, I'll see you guys tomorrow.
David,
seriously.
I keep getting a number that's above the mean.
Okay. So let's figure here. What we're doing is we've got x, which is, in this case, it's going to be 0.126. Or, excuse me, z. So let's plug in the formula. It's got to look like z equals x minus mu divided by standard deviation.
Yes.
So if we plug in the numbers, we have on one side of the equation z, we've got 0.126 equals x minus 542.3 divided by 120.54, right? So
Yes, that's what I have.
So let's go 542. Let's add 542.3 on one side, right?
Well, what I would do is multiply the 120.54 on each side to get rid of that.
So we can do that, yeah. I'm going to take the 540. I want to get rid of 542.3 at least, and I'll move it to the other side, and I'll add it to what 0.126.
Yeah.
And then we have to multiply something. Well, I wrote this down in some of my homework here, but this isn't to make sense. If I get that out of the way, then I'm left with x divided by, so I multiply by 120, but that's going to give us this massive number, which isn't right. Yeah, that's, oh man. I'm stuck on this one. Kristen, do you remember how we solved for x?
I'm sorry, which number are you on?
27.
Find the, oh, with the percentiles?
Mm-hmm. You
I,
plug 10th into the top, get the z-score, and then you plug z-score into the formula, and I can't quite remember the formula.
okay, let me see if I can find it. Would it be percentiles for normal distribution?
Yes.
Oh yeah, here it is. So it says, type in the percentile. Okay, so it says using the normal probability applet, click on the areas. So will you guys go into lesson 5, part 2 with me? And then click on percentiles for normal distribution, and it gives the formula right there. And I don't quite understand it. I don't quite remember how to do it. So if we all go there together.
And this is which lesson from week 2?
It's lesson 5, part 2, the video.
Well, that's got to be week 2.
Oh yeah, sorry, yeah, that is week 2.
Okay.
Okay, so what we do is we go to the normal probability applet, and then you type in, so it's 10 percentile, so we would type in 0.10.
Can you come out real quick? It's okay, no one cares. Can I come in?
So in the area, type in 0.10, and then it says use the z-score under the left line. So the z-score for that, where did it go? Is going to be negative 1.645. Well, I guess it's going to be percentile.
Oh my gosh, David.
Yeah.
We have to use the negative z-score.
Are you sure?
Yeah, because that's the only thing that makes sense. Because if you were to do the just 0.126, then you'd get 557.488. If you were to use the negative percentile, the negative z-score, you get 527.11.
Okay, I'm seeing here. Looks like we know z. Okay, so I'm down on this page just under the second applet. So the original equation here is we have a z-score. So we're using the negative z-score, right?
Yeah.
Negative 0.126. We do do x minus, so in this case he did what? He times 5.3. Right? These are very... Okay, so he... Okay, so what he did first, I kind of get what he did first here. If we took these same numbers, let's say that I have negative, you know what, I don't think we have to take the negative, because in the end, that is going to be the only negative number, and our x, our variable, is going to be negative.
Okay.
In other words, the score would be negative. So
Okay.
we have to do deviation first. So if we lined this up and we had, let's just say that z is 0.126, it equals x, which we don't know yet, minus 542.3 divided by 120.54. Well, we're going to times 120.54, which means on the other side of things, you know what, maybe you're right. Maybe we do have to do a negative. We do. I think you're right. But let's just say I'm going to take 120.54, and because I'm timesing it to the right to get rid of it, I'll times it times 20.54 times negative 0.126. That gives me 15.81. 15.81. Now, if that gives me, okay, so I've got negative 15.188. So now I've got a minus by, add 542.3 plus 542.34 equals, so that gives me a final score of 527. It just seems like for a GMAT, 527 is an awful close score to the 10th percentile. It seems when you're in the 10th percentile, you're outside of one standard deviation, and yet you're not within one standard deviation. Or you're still within two standard deviations. Sorry if you can't see me. I cannot see any of you because I've got another screen up.
You okay?
Yeah, to solve for, so we've got z, sorry. My answer to that, of course, is a number which seems like, gosh, I thought the 10th percentile would be much less than 527. If 542 is the
mean.
But you know, we could double check our answer to get a z-score, and then it'll give us a percentile. So let me write that down. We'll just double check our answer. 527.152. If we do that minus 542.3, so 527 minus 542.3 equals, that's negative 15.148, and divide that by the standard deviation, right, of 120.54. That gives us a z-score. Can you punch this z-score into the applet, which is 0.125? because this just wouldn't make sense. Negative 0.125. What's left? What's shaded left of negative 0.125?
0.45.
Yeah, that can't be it. That's not 10%. 10%'s probably got to sit somewhere like it's got to have a z-score of, you know, negative 1.8 something or something. You know what I'm talking about? I can't remember how to solve for x here. Looks like I'm going to be searching and hunting through paperwork tonight to try to find how to solve for z.
1.281.
I'm going to run down real quick and grab my homework. Sorry, guys, are you still there?
Kristen's internet won't stop going in and out.
All right.
I know she's not on here anymore, but I am. So.
Right. Fair enough. I'm looking to look through the homework here.
Oh, you're fine. Go right on ahead.
And see if
I'm
I
just
put
trying
down,
to figure out where I can get this as well, so you're fine.
Just get rid of this. Okay, there you are. This is a lesson.
Oh, my back.
Okay. Okay, so what I wrote down for solving for x was it's going to be x equals mu plus. Let's plug these numbers in, and I think we'll come up with our answer.
Well, give me the equation, David, so that I can see it right in front of me real quick, because I can't find it in my notes.
So write this down.
X equals...
Hold on, let me put my earphone in here to hear you.
Oh, you're okay.
X equals mu plus z times standard deviation. So put standard deviation, z times standard deviation in parentheses, and then plus mu. That gives you your x score. So if we plug those numbers in here, and I get the phone out here, we're going to have the right answer. It took me a while to get through that stuff and go downstairs and...
Oh, you're fine. It's okay.
So in this case, my z, it was 0.126.
Yeah.
Are we going to go with the negative 0.126?
Well, let me do the positive real quick, and I can tell you if it looks about right or not. Because if it's positive, then it comes out to 557.488. However, if it's negative, then it comes out to the 527.11, what we had earlier.
I think it is. It must be the 527.11. It just doesn't seem to be the 10th percentile.
I know, and that's what's getting me. I guess because that's right. That's what's coming up.
Then solve for x. It's got to be the negative number because
It's
it's
gotta
got to be
be.
the negative because it's below, which gives us a negative 15.18. When you add that to mu of 542, it does give you the 5. So it's got to be the 5.
Okay, I guess. Hey, come on, this. Oh, here. 11. Sorry, my husband has this thing about giving me a kiss in public. He feels weird.
Yeah, I would feel like I had cooties. It would gross me out.
Oh,
I'm kidding.
don't you have like 6 kids?
I've got 6.
Okay, yeah, I thought that was all right.
We're a hugging, kissing family.
No, he was like, because I was like, dame un beso, and he was like, but the camera's on. He's funny.
Well, it's a shame that.
Oh, sorry, dame un beso means give me a kiss in Spanish. Sorry.
Oh, I know. It's Bésame Mucho, famous song.
Oh, okay. Sorry. I didn't know. I just didn't know if you knew what I was talking about or not.
Is your husband speak Spanish?
No, I do.
Okay. What'd you do? Serve a mission there?
No.
Just high school, college stuff?
I'm half Mexican.
I couldn't tell. Where are you from? Oh, Santa Fe.
My husband's from Santa Fe. I'm from Indiana.
Who's Mexican? Your mom or your dad?
My mom is from Guadalajara, Mexico.
About 8 hours south of here.
Yeah.
Okay.
So.
All right. Well, that's what I've got. How to solve that's which is the formula.
Yeah. So I would put down the 527.11. That's what I'm keep getting for it because good gravy. It's not going to be above the mean with 557.488.
No.
There's no way.
No. And maybe on the bell curve, that is the 10th percentile for the scores.
Probably.
Okay, we're just going to go with that.
The 527?
I guess so. So we're going to go with what, 527? I mean, even if we solve for it the other way, I'm still coming up with the same answer.
Yeah, it's the same here.
So for number 27, it's what? We'll come up with 521 point what?
527.11196.
So 527.112.
Yeah.
All right. What is the probability that a randomly selected student will score 600 above the G? What was the answer to 26? What did we get for that? I got
26 is 0.3160. So find the GMAT score that corresponds to the 90th percentile.
Okay. All right. We on to 29 then?
Yes.
All right. Find the first quartile.
Oh no. We're on to 28.
28.
So it's basically the same thing.
Okay. So if we do that the same way, and we plug in the z-score for what's the z-score for 90th? It's got to be the same, isn't it? Now it's a positive 0.126. It's got to be.
Oh, hold on a second. That's not right. Sorry, I have to fix this 0.9. I have. What do you have for the z-score on that? For the z-score, it pulls up because it's just the area under the curve, correct?
No, it's greater than 90th percentile would be above, greater than 90. So if you type in 0.9 at the top, shade to the right, it should be 0.126.
Well, for the z-score that comes up when I put down 0.9, it's 1.645. And that's just how, and that's when and I'm not clicking on anything as far as shading. It's just coming up as under the area of the curve.
Okay.
So I'm thinking that that's just the z-score.
It's got to be, well, if that's 90th, if that's the 0.90.
Yeah, when I go to the normal probability applet and go to the area and I put 0.90 and click off of it, it takes me directly to the area under the curve being highlighted and the z-score being 1.645.
All right. So if you'll forgive me just a minute, I'm logging into the applet one more time.
Oh, you're fine. Hey, I just want to tell you thank you for being so patient with me, even though I can get really, really short-tempered.
Oh, I work with a girl at work who's half Mexican, and she always claims that it's her Hispanic passion.
Oh my gosh. I think that's a terrible excuse. Oh my gosh, that's awful. Oh my gosh, that's terrible.
She says it jokingly. She's a pre-med student working as a paramedic on the helicopter.
That's so funny.
She says that in funniness, but
that's funny.
We all like to laugh along with it.
It's pretty funny. Oh, it cracks me up a little.
Okay, so normal distributions. When we're working in the ER, one of the chief head nurses in the ER is a Hispanic woman named Margarita. And whenever there's a Hispanic woman who comes in to the facility who's just like all freaked out and breathing fast and very emotional, and she calls it, it's just HP, guys. It's just HP, which stands for it's Hispanic panic.
It's Hispanic panic.
Whatever that means, I do not know. Okay, so I'm going to put in 0.1 here. Oops. Now, you know what? We're wrong. You know, when you put in, this is why we're having a problem. I think I understand. So go into your probability applet.
There.
Type in 0.1 to the top area, not the z-score, to the top.
To the area.
Then click outside of it. What does it give you for a z-score?
On the bottom or?
Yeah, bottom left.
And click out from under the area?
Yeah, get out of the box and click, and what do you get?
0.4499 in the area.
Okay, so we got to be doing something wrong here. Okay, go into the area once again. Get in there, clear everything out, and just click 0.1. Go out of the box, and then click on the white of the screen outside the box. And tell me what your z-score says down below. Mine says negative 1.645.
That's what I'm getting as well.
Okay, that's why we're having. That's why we didn't get the 10th percentile.
Oh my gosh, David, I'm so glad you got on there because I was getting so confused.
So you got to click your percentile into that area, then go out into the white area and click again. Once you do that, your z-scores will populate. Now, arguably, for the 90th percentile, you're going to get the same numbers. Click at 0.9. Well, not quite the same numbers, but that's 90th percent, which means that 90th percentile. Let's see. 0.9. Oops. This isn't allowing me to click out here. This is weird. 0.9. Why is it doing that? Okay. For the 90th percentile, we get just a little bit of a different score, which is 1.282. That's what you got for when you clicked it in, right?
Yeah, I got the 1.282, but for the 10th percentile, 0.10, let me enter that back in. What do you get for the
It's
10%?
0.10.
Yeah, 0.10.
Now, we should get the same, 1.282, because you want to shade to the left of the low bar, or the red bar.
Yeah, and I also get 1.282.
Negative. So it stands to reason that anything above 90% is the same z-score as anything below. Anything above the 10th percentile is the same z-score as anything below the 10th percentile. Just one has a negative and a positive connotation. So if we recalculated our formula here, and we did, okay, let's redo the formula. We've got, the formula is, so we've got y. Let's do the z times standard deviation. So now with our new z, let's go, we're going to go for the 10th percentile, negative. So negative 1.282. We're going to times that by our standard deviation, which in this situation is 120.54. That gives us a number which is 154. Now, that's a much better number, because if we take 154 and minus it, or just add,
Did you get 387.767?
well, I'll tell you right here, 542.3 plus 387.76. That's a 10th percentile score.
Yeah, I would just say that. Okay, that makes more sense.
So
Okay,
for that,
I
we
was
can
just
put
doing that
down,
wrong then.
yeah, it's all right. So 10th percentile, we're going to say our answer is 387.76. I'm going to call it 768 rounded up. If we do that same score, 1.282 times 120.54. Now we're going to have a positive 154 plus 542.3. Our 90th percentile score is going to be 696.832.
Did you say 696.8?
0.832. And if I added that wrong, I'll double calculate it just to make sure. Did you get the same number?
I'm double checking real quick.
So let's see here. I had a 1.282 times.
$696.832 is what I got.
All right, we're good. So that concludes 27 and 28 question.
Oh, finally. Find the first quartile of the distribution of the GMAT scores.
Which means we would both have to log into SPSS.
Oh, crap. Sorry, one second.
So
my legs are just really tight.
I've got to, here's the bummer about SPS is that I've got to download an SPS into, we've got to download all these scores into the, well, no. We just have to go into the, we've got to go into the, where was that SPS? Which, just have to find where the SPSS is. Which lesson had SPS on it? SPSS. Do you remember?
No, I don't.
And I hate being so late here because we're kind of running late, but
It's okay. Don't worry about it. We're getting our work done.
So that's going to be
Yes.
lesson 4.
I was going to say, yeah, week 2, lesson 4, because it was with probability and stuff.
Okay, so I'll bet you it's in lesson 2 or 3, which made you go to an SPSS, but let me just see if there's anything in lesson 4, which takes me directly to the SPSS. There's nothing in that lesson, which takes me to that. Oh, maybe. Where's the one where we had the baseball players? That's probability. I'm going to go with that one. Probability and discrete. That's, maybe it was the right thing. Sorry, I'm trying to find that.
No, you're fine. Are you talking about the link?
Yes, the link for the SPSS that has all the different.
It has all those different options on it?
Yeah. For which
Okay,
one to
hold
log
on
in.
a second. Where did I find that? I had that somewhere, and I know I did.
It's
Okay.
not in lesson 4, that's for sure. I'm going to go to lesson 3 and see if it's there. Okay, I think it's in lesson 3. It's going to give me a. Computer's froze up there for a minute. Okay, so here it is in lesson 3. Let's go to a. Why is that not allowing me to get into that? Okay, here we go. Diving elephant seals. This will take me to at least the main, and we're talking about the GMAT. So let me go down to the G. I don't see anything for the GMAT scores.
Neither
First
do I.
quartile. Well, you know what we could do for the first quartile? I mean, I guess you put in the third quartile. I guess we could put in the 25th percentile, 75th percentile to get the number.
Well,
It just doesn't give us a. Oh, you know what? Hold on. I might be in the wrong. Let me move down some. Nope. I'm looking for GMAT scores on this SPSS end. Goodness. I thought it would be in the standard deviations.
well, couldn't we do basically the same thing? Because it's talking about the GMAT scores that correspond to the 10th percentile. So couldn't we do that same thing except for put in 0.25 and do the
Yes.
same thing with the third quartile and put 0.75 and then do the exact same equation?
Yes, we could, in theory. Although, when we looked at that previous, sometimes the percentile doesn't necessarily say, because you've got these outlier numbers, and so it's the 75%, 75th percentile always isn't that same number. You just might have, 75% between 25 and 75. That's where the greatest amount of data is, but it doesn't necessarily mean that the 90th percentile is up here. Whatever. Does that sound too complicated? Yes, we could. We could try it that way. It just doesn't always mean that we're perfectly going to get it. The only
Yeah.
thing I could do is I'm thinking about going into this iLearn and going into week 4 and seeing if there was a GMAT download from the book itself. like review for exam. Let me just look real quick. I'm going to see in here, was there a GMAT highlighted thing I could download? And Crossroads purchases data file is there. But I'm not seeing a highlighted thing to log into the GMAT, which is kind of a bummer. We're just going to be winging it, I guess. There's nothing there for us.
Well, for
Let's plug in 20. Let's plug in 25th, which will give us a z-score, and then we'll calculate our z-score. So I'm getting back down to the applet here. Okay, so 0.25. Okay, so the 25th percentile gives us a score, a z-score of negative 0.674. So if we have a z-score of negative 0.674, we can plug that into our formula, right, for their GMAT?
yeah, to get 460.756.
Oh, you've already, damn, you're quick. All right.
And then for the 90th percentile, it would go up to 623.544.
You've got 460 point what?
460.756 for the 25th percentile.
Got it. And then for the
90th
third,
percentile,
well, actually, don't do the 90th. It's the third quartile for number 30, or 75th
I'm sorry.
percentile.
Let me double check that one more time.
I'm going to go
0.75. 0.75.
It gives us a positive score of 0.674.
Yeah, which is 623.544.
Had you already calculated these?
Yeah.
All right. I know we want to get done quick. I'll just trust you on that. So, do you want me to work it real quick, or just?
No, feel free to work it. I mean, I just did it as we were just now as we were talking. So I just wanted to make sure I that's what I got. So go ahead and.
I'll just double check you. So if we go 0.674, and my 0.674 is times the 120 point. What was it?
120.54.
Times 120.54. That gives me 81.23. Or excuse me, yeah, 81.243.
Yep.
And then I'll just add that to what, 542.3?
Yep. And then you can do the exact same thing, except you're going to take 542.3 minus the 81.243.
So for number 30, I've got 623.543.
Yep.
Or call it 544.
Yeah.
And then on the, well, yeah, now if I was going to get below that, I could go minus.
Yep.
Okay. Consider taking a random sample of n minus taking the GMAT.
Okay.
Why would we consider a random sample?
What are the means and towards your all samples?
So what are they asking for? So we get to get the mean?
Yeah, because that continues on to 31.
Oh,
What are
yeah.
mean and standard deviation of the distribution of sample mean scores for all such samples?
All right, we know how to do this. So if we had
Well, the thing is, though, is that we don't have another score. I mean, because we have n equals 15, which we would take z equals.
the mean is going to be the same. The mean
What?
will be the same. Because remember the mean?
Yeah, the 542.3 will stay the same.
No, yeah, 542. So the mean's going to stay the same, 542.3. The standard deviation will change, though. Because now we're going to do, everything's going to be divided.
Yeah, but would we take 500 minus 542.3 divided by 120.54 divided by the square root of 15?
The only thing that we do for the standard deviation in finding, once we've got the n, is we take the standard deviation and divide it by the square root of 15, correct?
Yeah, the standard deviation would be 120.54 divided by the square root of 15.
So square root of 15, and you've already got these answers, correct?
I haven't done this one yet.
So the square root of 15 is 3.8729. How? It's a big long 12. I don't know how to. But if I take that, I can just take it out to 5 numbers for argument's sake.
31.1329.
All right.
That's what I get for the standard deviation when you take 120.54 divided by the square root of 15.
All right, so 120.54 divided by 3.87298. I'm getting 31.123, same as you pretty much.
Yep.
So the standard deviation is going to be 31.123. And then the of sample means, yes, those are the two answers, right?
So what are the mean and standard deviation of the distribution of sample mean scores?
Well, the mean's going to be the same because the mean doesn't change, right? So
yeah.
We're still talking about 542.3, but the standard deviation changed from 120.54 to 31.123.
Yeah, because the mean wouldn't change because the mean would be the same thing as the sample mean.
Right.
So it would just be those two answers then.
Right, and so the central limit theorem says, hey, as the sample gets bigger, your mean just gets closer to the middle. I mean, your mean gets more centered. The law of large numbers says that as things get, as you get more numbers in, you're going to have your standard deviation gets smaller and smaller.
Yeah.
And in this case, it already has.
Mm.
All right, so 32.
32. I just calculated that. I got for the percentage, I got 0.0319.
Okay, so essentially we're talking about 600 minus 542.3.
Yeah, divided by 120.54 divided by the square root of 15. So you could take 600 minus 542.3 divided by the 31.123.
All right, so if I set this up, our standard deviation is 120.54. That's going to divide it by our
the square root of 15.
Which we got is what?
For 31, it's 31.12329.
All right, let me just do my calculation real quick, see if I'm getting the same number as you. And 57.7 divided by 31.123. Are you getting 1.854 essentially rounded up?
Yes.
Okay. All right. Now, before we go on, and before we take this test, I just want to check real quick. Back on page 8, or on number 19.
Let me go back. Let me get there.
Notes here.
Ah! Oh, wrong again. Okay, go ahead.
And when we were going through that, I want to make sure that because all of a sudden, I don't know if this happens to you, but we're getting in the middle of this. I was confused. I went to this guy's house. Of course, I wrote down some notes on blue paper here. And I got these numbers written down, and yet now I'm all confused about how I got there. So, for instance, number 20, estimate the mean. Okay, I know what the mean is, 2.055. Question 21, estimate the standard deviation of the measured nitrate concentration in rectified drinking water. Remind me how we did that again, because I wrote mu.
Yeah, so you would take the 2.055 and then subtract the 1.59 to get 0.465. Okay, so in the paragraph above, it's talking about how 1.59 parts per million is the value of 2 standard deviations away from the mean. So 0.465 is 2 standard deviations away from the mean. So you would divide that by 2 to just make it 1 standard deviation away from the mean, which is 23 is 0.2325. So if you were to check that again, you would take the, I did it a little bit differently, but I put the 2.52 minus the 2.055, which is what we found as our mean, to get the 0.465 again, because it is also 2 standard deviations away from the mean. And then you divide the point. Go ahead.
The 0.465 represents 2 standard deviations, right?
Yeah, because if you go up to the top, up to the paragraph, it says we will assume 1.59 parts per million is the value of mean minus 2 times sigma. So 2 standard deviations away from the mean. Okay? And and then mean plus 2 times sigma is equal to 2.52, which is again 2 times the standard deviation, which is 2 standard deviations away from the mean.
So then, once again, if we took the 2.52 minus 2.55, we would get the positive
2.055.
Right, 2.0. We would get the positive 0.465, which is the 2. Now, if it said estimate the standard deviation, we're talking about, when they say standard, we're just talking about, we always equate that as 1, correct?
Yes.
So it would be half of this, which would be, what?
0.2325.
Hold on. Yeah, so 0.2325, which is what I have. And then when I got those two numbers, number 22, between the two measured nitrogen.
So 68% is just 1 standard deviation away from the mean. So you would subtract 0.2325 from 2.055, and you would add it as well to get on both.
1.8225 and the 2.2875.
Yes.
And then lastly, what is the mean and standard deviation of the standard normal distribution? Okay, so that's when we have to add in. How do you know what the mean is on this? Well, okay, we know what the mean is already. The mean
is we'd have to put our mean. So what is the mean? It would be the 2.055.
And the standard deviation, what do we have? 2 samples here?
Yeah, and so standard deviation of the standard normal distribution.
So for a standard, our 1 standard deviation on this we figured would be what? 0.2325?
Yeah.
And we're going to divide that by 2.
Why would we divide that by 2?
Oh, I'm sorry. I thought I was asking for the sample mean. No. So that gives us our 2 answers are 2.055 and 0.2325.
Yeah, because that's the mean and the standard deviation.
Man, I don't know why I was having a block there. All of a sudden I got a panic. Like, how did I get to that? And it makes sense again.
No, it's okay. You're fine. I've had those all night tonight.
All right. I think we've got to take the quiz now, right?
Yeah, we do, because that's due by 11.
We're running out of time.
Yeah.
All right. Let me get to lesson 8 here.
As will I. Let me get there. I have so many of these folders open right now.
Oh, so do I. In fact, I got to get rid of some of these. I just can't. I got to get out of this.
Oh, here we go.
I got a 4.
Group meeting.
I'll leave the probability applet up.
Yeah, definitely leave that one up.
Let me get to the group meeting. I can't believe we have a 35-question quiz.
I know.
30-question quiz.
All right, are you ready to start it? Ready?
Almost. Hold on, almost. I'm logging in. It's making me relog back in.
Oh, you're fine. Just let me know when you're ready and we can go through it.
Okay. I have a really high-priced Acer computer from Taiwan, so my data doesn't come up as quick.
Oh, okay. I'm just an HP fan. I love HP.
Well, I tell you what, HP took a back door to 6 kids in a house and all that stuff. So yeah, we've got the 200 and well, $300 version, Target version of the laptop here.
Uh,
Okay, just going to group meeting for lesson 8.
yep.
And there's my doc. Where is my quiz? Here's my quiz, and we are ready to start. 1, 2, 3. It says, am I ready to start now? Yes, I am. Holy camole, that's a bunch.
Uh,
I guess we don't need to have this. Yeah, we do. Okay. I attended my group meeting preparation. Yes. Which of the following variables is okay? Well,
so we said the toothpaste.
yes. So another. It's not A and B. It's going to be just the second one down.
Yeah, just B.
Brand of toothpaste. Question 4. Should I just let us read these quietly? I'll just do that.
I mean, we can go through them together if you'd like, just to make sure that we don't mess anything up. I don't mind at all.
Okay.
So for number 4, we said that the parameter was the 100 and that the 120 was the statistic. Or the 112, I'm sorry, the 112 was the statistic. Yep.
So 100 is our parameter. Yes. Okay.
Okay, and then for number 5, we said stratified.
Let me just make sure, get back on these papers here. I've got them all messed up. 1, 2, 3, 4. Okay, I think I'm back to, okay. Sorry, missing a paper.
Oh, no, you're fine, David. It's okay. I don't mind at all.
Okay, there's page 5. So I've gone through that. For number 5, we've got stratified.
Yep, and then for number 6, we had simple random sample. For number 7, sorry, let me scroll down a little bit. There we go. For number 7, we had, oh, I'm sorry, I'm getting this messed up. I'm reading these incorrectly. So for number 5, we had a stratified sample. For number 6, we had a cluster sample. I'm sorry.
Yes, we did.
And then for number 7,
real quick,
we had
number 6. Do we actually have the same question?
when designed experiments. Oh, wait, oh yeah, let's read these. You're very good idea.
Fourth grade students in that district, and that was for number. Let's see, 4th grade student in that district. Yes, same one. Okay, so it is cluster.
All right, and then number 7. Let me read it. Tell me if it's the same as what you have on your paper, okay? At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Okay, so that's the same.
Simple random.
So simple random sample, yeah.
Okay.
Okay, and then let me scroll down just a little bit more. Number 8.
On this.
A special interest group is conducting National Park. Gauge opinions adequately on people. So that number 8 is also the same, and I put stratified for that one as well.
Stratified random.
Yes.
Stratified. Okay.
Okay, so number 9, calculate the mean of these data. The mean I got 4.771. And the standard deviation was oh wait, hold on, how many round to 3 decimals? Okay, yeah, that's right. And then number 10, I got for the standard deviation, it's 1.912. Okay, and then number 11. Number 11, I created a oh wait, that's something. I created a histogram representing the amount spent in crosswords per student. Yes, I did. Okay, let's see. Number 12. Are you on number 12 already?
No, I was on number 11 because I did not create that histogram, and that had to be through our own SPSS. Was the histogram part of the iLearn? Was it on that screen?
Yeah, it was on the when you were, oh gosh, when you know how when you went to go print off the actual study guide.
Yes.
So it's on that site. It's on that site where it talks about, create a histogram. It gives you the link to click on it and everything.
Hold on. Allow me 60 seconds. I'm looking for that Crossroads purchases. Let's make sure that, and it was Crossroads purchases, correct?
Yeah. So it'll say
I'm
open the
sorry,
data
I have
file.
got to. I have to answer that one false unless I do this.
It's okay. Oh, crud.
I know we all want to get to bed here. I apologize for not
Oh,
being
it's okay. Thankfully, I have the day off tomorrow, so.
Right.
What is the value of the
Mine's just spinning right now.
number?
Thank you for being patient here.
Oh, it's okay. I mean, because if anything, we can skip that one. You can skip that one and we can move on, and if you want to finish that afterwards, we can do that as well.
In fact, let me just get back, and I will, before I submit, I will have created that, so.
Okay, I'll just make sure to remind you before you submit.
Hold on, it won't even let me go back into my. It's slowly bringing up SPSS, but because I have so many programs running, it's running colossally slow.
That's okay.
Forgive me. All right, so which number are we on anyway?
12.
12. Okay.
So for number 12, I had, okay, so what is the value of the number that goes in the A? Which on our sheet is number 11.
Hold on, here it is right here. Give me just 1 second.
Oh, you're okay.
So I go under, let's see, graphs, and legacy dialogues, and histograms, and there it is. And we have to put, is it mount method or source on that one? Can't remember. You can go to the bottom for a minute. We'll come back to that. Back to present. Okay, I'm getting back to us. Sounds like a marriage theme. Okay, number 12.
So yeah, what is the value of the number that goes in the position marked with A in the table above? So that's number 11 on our sheet, and that is that's negative 0.165.
Yeah. So I've got negative 0.165. 13. What is the value of the number that goes in the position marked with B? On that one, it's just going to get 3 decimal places. So on that, we would be 0.681.
Yep.
And that is for 12.
And then for number 13, what did we decide on that one? It's 14, but 13 on our paper.
We're going to go with the variance. And if you're right on this, you tell me how you want to roll with it. I mean, it's either the variance or none of these is correct.
I know, and we never came to a conclusion on that.
By the way, are we supposed to be taking this together or not?
I thought, because since it was a group meeting and a group quiz, like that's what I read.
Yes, let's do it. I'll just keep going. And if it's an error, then it was an honest error. Do we try to overthink this and go with none of these correct, or do you want to go with variance?
Yeah, it probably is the variance.
I'm gonna just stick down variance, and if they're trying to get too cute, then they're getting too cute and they foxed me.
Yeah. Well, I guess we'll find out when we submit it, right?
Yeah. What is the standard deviation of these temperatures? Rounded.
0.715 is what we got.
Yeah. 0.
And then number 16, we had false for it because it can't be less than 0.
Correct.
Okay, let me scroll down a little more. Which location resulted? We said extradural because it had the smallest standard deviation, right? That's what I had down. I can define standard deviation in my own words. True.
Yeah.
All right. What is the third quartile?
Hold on. I can define standard deviation. Yes, I can define it in my own words. It's a measurement of the how far one score or performance is away from the mean, either above or below. Correct?
Yep.
All right.
So what is the third quartile? We had 8.
Third quartile, we had 8.
And then what percentage of the data lies? We said 50%.
Yes.
Estimate the mean measured nitrate. We said 2.055. And then 22, estimate the standard deviation, which we said was 0.233.
0.23. Yeah, it'll be. You're right. So. 0.233.
And then we said that it would lie between 1.8225,
yeah.
so or 1.822 and 2.288.
And I have it's going to be between 2.2875, or 288. So we're choosing the bottom one.
Yep.
What is the value of the mean of a standard normal deviation? What is the value of the mean? 24, we put down that was
2.055.
We're talking about the.
Because what they did is they took 23 and split it up into 2 questions.
Hold on. The question 24 is different than the question 24 in the quiz.
Well, that's because they split it up. All they did was because let me read 23 in the paper. Okay. What is the mean and standard deviation of the standard normal distribution? Now, if I were to break that up, what is the mean of the standard normal distribution?
2.055, and then the standard deviation is 0.2325. Hold on. So question 23 on the test, we just did that. Question 24, I guess what I'm saying is from the paperwork we did, this 24 is not the same as the 24, because 24 here is to do with the GMAT. So let's make it proportional to the, what is the value of the mean of a standard normal distribution? Normal. But what's its value?
And it's corresponding to the parts per million with the City of Rexburg reports for the nitrate.
We're just talking about 2.055, are we not?
Yes, it is. So for 24 on the quiz on the computer is 2.055. For 25 on the computer, it's 0.233, rounded up.
Because we took the value of this. What is the value of standard deviation of a standard normal deviation? And our standard deviation was the 0.2325 or 2.233. That's our standard deviation, right?
Yep, 0.233.
Right. 26. What is the probability that a randomly selected student will score 542.3 on the GMAT? Well, we decided that that was what, 50%?
50%, so it'd be 0.05. Or 0.5, I'm sorry.
All right. I just put 0.50.
Yeah, that's what I put.
The probability that a randomly selected student will score below 600 GMAT, I think on 27 we decided that that number for 27,
0.684, which is number 25 on our paper.
yeah, so what is the probability that a randomly selected student? That's number 25 on ours. And we came up with 0.6840.
Yeah, so it would just be 0.684 because of 3 decimal places.
What is the probability that a randomly selected student will score 600 or above?
And for that one, we got 0.316.
The GMAT score for the percentile. Well, this one we finally figured out. So the GMAT score we came up with was what? 460.756?
For the 10th percentile, it's
20. 387.768. Round to the nearest whole number.
so 388.
388.
And then for the 90th percentile, it'd be 697.
And if we 697.
So, and then for the first quartile, we had 460. It'd be 461. That's rounded up. And then for the third quartile, it'd be 624 rounded up.
Okay, so 461 was rounded up from 460.7. Switching pages here, and the third quartile is 624.
Yeah, because that's rounded up with the 0.5.
Right. 624. Consider a simple random sample. Mean distribution samples. All right. All we did on that was we took our standard deviation. What is the mean of the distribution? Well, we know the mean of the distribution is the same as the other mean, which is what, 542.3.
33. Consider simple random. Mean of the distribution sample mean.
Okay, what is the mean of the distribution of sample means for?
It was 542.3.
Right, because it's the same mean.
Yeah, it's the exact one. It's the mean of the sample means. What is the standard deviation of the distribution of the sample means? So it'll be 31.123.
Which is what we came up with when we shot that other. Yeah, I came up.
Yeah.
I've written on. Hold on, let me just. Where the 31.123.
Yeah, 31.123. And then for 35, what is the probability that the sample mean GMAT score for an SRS sample random sample of n of 15 students will be greater than 600? We got 0.032.
What is the probability that GMAT? Oh, so I don't. Did I even? We got. I haven't done. I didn't finish this one out here. If you wrote this down.
Yeah, it was 0.032.
All right, I'm gonna work it with you real quick, and then you can get out of here.
Oh, you're fine. Go ahead. I'm just going through making sure everything's where it needs to be.
So we have 57.7, and that 57.7 is going to be divided by 31.123. We got 1.854, correct?
For the z-score, yeah.
That's the z-score.
And then when you go to enter it in.
Let me just put that up here real quick. So 1.854. It can't. That's the z-score, right?
Yeah, the 1.854 is the z-score.
Or the chances that it'll be greater, correct? Is that the question? Go back to the either in here. Okay, what is the probability that GMAT will be greater than 600? And for that, we are saying that the chances it will be greater is all of 0.0319. So we're going to say 0.032.
Yes, sir. Okay, I'm submitting. I've already looked through it and made sure everything was answered.
Okay, I'm just going to double check mine to make sure that I've answered everything. Gosh, I hope I didn't put these in the wrong spot while we were chatting.
Hey, we did a good job.
Do okay?
Yeah, we did do okay. There was one that we didn't get correct. Oh, I was right! I was right!
It's none of these, huh?
Yes, it is!
Okay. Hold on.
Oh, man, I'm... Darn it, Dave! Just kidding.
Okay, I've got to go on the Crossroads purchases really quick.
Okay.
Otherwise, I can't say I was honest, Abe. Okay. So we went into graphs, legacy dialogues, and history.
Ah, darn it. I just need to go with my gut. If that's the only one we got wrong, I'm going to yell at you, David. Do you understand me? Okay, just kidding. We got 2 others wrong.
All right.
We did a good job. We did a really good job, Dave. Do you care if I call you Dave?
Yeah, it'll be just fine with me. I'm fine with that.
Okay, just you know, because it just comes out. My dad's name's David. My brother-in-law's name's David. My cousin's name is David.
I am just looking at this. In order for me to answer correctly on this, I have to... Okay. I see the deviation. I see the mean. Okay. I can honestly now say that I have done that. Okay, yes, I did create. It's a good thing I looked back through, otherwise I would have submitted and forgot all about that.
Not bad. Not bad.
Okay, good. I'll take that.
Did you get a 91?
Yeah. Hey, we did good.
Yeah, we did.
I'm glad we worked through that. Good luck tomorrow on your test.
As well as for you. Good luck.
Yeah, I actually fly tomorrow, so I called Brother Richmond tonight and said, hey, I'm going to be, if they call me away for 9 back-to-back flights, will you give me some latitude? And he said, well, if that happens, call me and we'll work around it. So just, it's going to be, I probably need a couple of 2-3 hours to get through that test. And it was very helpful to work through this tonight.
Yeah, it was. I put my mind at ease because now I'm like, okay, I actually, I know what I see what I know and what I didn't know and what I was able to work on and figure out. So it was very much helpful.
All right, I'm just getting all this stuff out of here so that, I'm getting all those screens off here so that I can, okay. I'm squared away. You feel pretty good about things?
Yeah, I do.
All right, do we need to meet Thursday night also for that thing?
Yeah, we have a whole nother lesson to do on Thursday.
All right, unless you tell me otherwise or unless the girls communicate otherwise, I'll consider 8:45 Thursday night. I'll host again.
8:45 on Thursday?
Yeah.
Okay.
All right. Success to you tomorrow.
As to you.
All right, have a good night. I'm going to stop broadcast. I'll post it.
All right, have a good one.